Hello class, welcome to Unit 5, Video 2. Today we're going to look at permutations and combinations. Your learning target for today is that you can solve problems involving permutations and combinations. You're also going to need your calculator today, so make sure you have that along. So, when the manager of a softball team fills out her team's lineup card before the game, the order in which she fills in the names is important because it determines the order in which the players will bat. Okay, so order is important. So suppose she has 7 possible players in mind for the top 4 spots in the lineup. Using the fundamental counting principle, how many ways can she assign players to the top 4 spots? So I have 4 spots. In order matters. Okay, so for the first spot I have 7 to choose from. Then I would have only 6 because if I put a person here, they can't bat again. So there's 7, then 6, 5 times 4. So if I multiply this out, there's 840 ways she could do those top 4 spots. This is an example of a permutation. A permutation is when order matters or order is important. Okay. So permutation, when a group of objects or people are arranged in a certain order, the arrangement is called a permutation. So order is important. One thing to remember is if I put 2 things in order, A, B is different from B, A. Okay. So order is important. The way we calculate permutations. Okay, the number of permutations, n distinct objects taken r at a time, is given by P of n comma r. So for instance, we were taking a permutation before. We had 7 people and they were being arranged 4 at a time. So that would be P7, 4, 7 choose 4. Okay, and so it's n factorial over n minus r factorial. That's how this is defined. So with our example, it would be 7 factorial over 7 minus 4 factorial. So 7 factorial over 3 factorial. And we could do this by hand. One thing to remember is factorial. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. That factorial means you just start at that number and go all the way down to 1. So 3 factorial is 3 times 2 times 1. And if I simplify, my 3's would cancel, my 2's would cancel, and my 1's would cancel. So on my calculator, I'd be left with 7 times 6 times 5 times 4, and we found the answer of that before. The good thing to know is that you can do this on your calculator. Okay? If you ever need to do a factorial, I will show you where that is. You might have to look. So if I want to do 7 factorial, you type the number 7, and then you would go math over to prob for probability, and number 4 is the factorial. So that's 7 factorial. So that's 7 times 6 times 5 times 4 times 3 times 2 times 1. So if you ever had to do a factorial, that's where you could do it. If you ever wanted to do a permutation, if I wanted to do 7p4, you would type the number 7, you would go math over to probability again, and notice a permutation is number 2. Enter, and then I would type 4 because I'm taking 7 items and putting 4 of them in order, and that would be my answer, which is what we got in our example above. If you have a TI Inspire, okay, so on the 84 it's 7p4. On the Inspire, you would do P, you have to find the permutation button, and then it's 7, comma 4, and your comma. Okay, if you have any questions on that and on how to find it on your calculator, please let me know. Or you can use YouTube to look it up. So an example. Okay, there are 10 finalists in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? Okay, so does getting bronze versus silver, is that different? Yes. So order matters. Okay, so it's important that we are arranging these skaters in first, second, and third. That's why it's a permutation. So Sally winning the gold, Susie winning the silver, and Judy winning the bronze is different than Judy winning the gold, Sally winning the silver, and Susie winning the bronze. So it's good to notice that when you're doing a permutation, it's when order matters. So this example, we have 7 total people. So sorry, not 7, 10 total people, and we are putting them in order for 3 things. So 3. So it's 10p3. On the Inspire, it'd be p10, comma 3. If I plug it into my equation, if you don't have a calculator that can do a permutation or combination, you have to remember the equation. It's going to be 10 factorial over 10 minus 3 factorial of that. So I really have 10 factorial over 7 factorial. If you don't have a calculator, one nice way to simplify is 10 times 9 times 8 times, I'm going to write it as 7 factorial, so I don't have to write it all out. Those would all cancel. And so I really just have to do 10 times 9 times 8. Or once again, I can go on to my calculator and type it in. So I would type 10 math, go over to probability, permutations number 2, so I can arrow down, enter, and 3. And my answer is 720 ways. That's example 1. Example 2. A newspaper has 9 reporters available to cover 4 different stories. How many ways can the reporters be assigned to these stories? Okay, so does having a story on the crime in the city differ from the fashion? Yes, it does, so order matters. So we have 9 people, and they are being assigned to 4 different, or arranged in 4 different stories. So it's 9p4. So I can write out my equation. So it's 9 factorial over my n, 9 minus 4 factorial. So it's 9 factorial over 5 factorial. And if, once again, don't have a calculator, I would do 9 times 8 times 7 times 6 times 5 factorial over 5 factorial. Those cancel, and I would type this in my calculator, or I can just go to 9 math probability. Number 2 is permutation on there, and then 4. And my final answer is 3,024. So they can assign the stories in 3,024 different ways. All right, moving on to example 3. How many different ways can the letters of the word geometry be arranged? So we're looking at the word geometry. So you would think, well, there's how many letters in geometry? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 letters, okay? So you would think maybe it's a permutation of 8 things being arranged 8 different ways. So it's really, if I plug it into my equation, it's 8 factorial over 8 minus 8 factorial. So I have 8 factorial over 0 factorial. One thing I want you to know, and you will need to know, is 0 factorial. If you plug it in your calculator, it's 1. So I really have 8 factorial over 1, so it's 8 factorial. Okay, so there is 40,320 ways to arrange those letters. There is a problem, however, with these letters. Okay, is there any repeats? Is there any doubles? If I look there, there's only one G, but there's 2 E's. So whenever there is repeats, okay, we have 2 E's, I need to take those into account. So if there's ever repeats, you take the total number of letters factorial over the number of repeats factorial, so 2 factorial. So this gives me 8 factorial over 2 factorial. We just said 8 factorial is 40,320 over 2 factorial is 2. So my answer for 3 is really 20,160 ways. You need to be careful. If there's doubles, you need to divide out by those. So that brings us to permutations with repeats or repetitions. So the number of permutations of n objects of which p are alike and q are alike. So it means that there's double letters. So you take the total number factorial divided by the number of repeats. Okay, biggest thing is just maybe let's try another one. How many ways can the letters of Mississippi be arranged? So the first thing I would do is count up how many total letters do I have. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So I have 11 factorial over. Clearly there's letters that repeat. The first one is I. How many times does I repeat? There's 4 I's. Then there's S, there's 4 S's, and P. There is 2 P's. So I would have to do 4 factorial, 4 factorial, 2 factorial. This is going to give me my answer. So this one is clearly easier to put in on your calculator. So I would do 11 factorial. So go to probability. Remember the factorial is in there, number 4. Here's where you gotta be careful. Divided by, now put all of this in parentheses. So 4 factorial times 4 factorial times 2 factorial. Well, 2 factorial is just 2, so I'm gonna say 2. End the parenthesis, hit enter, and you get that there's 34,650 ways. So you can rearrange it that many ways differently. Okay. Any questions on permutations, please write them down or come and ask. Otherwise, we're going to go ahead and move on to combinations. So think about a combo. It's a arrangement of selection of objects in which order is not important. It is called a combination. So if I combine things, I think about groups. So it's when not important. Combination, I think about groups. Okay, so order is not important. So AB is the same as BA. If you're talking about my husband and I, it's the same as saying my husband and Ms. Meyer. I mean, it's the same combination, so they are the same. Okay, so think about groups, committees, those types of things. So the way that a combination is it's n factorial over n minus r factorial. Okay, the only thing new is it's also divided by r factorial. So that is how you would calculate a combination. So it's n distinct objects taken r at a time. And once again, on your TI 84, it's going to be NCR. It's the same thing. Inspire is going to be written this way. All right, I look at example 4. We're going to have to look at these and decide permutation or combination. But it says a group of 7 students are working on a project, needs to choose 2 students to present the group's report. Well, order doesn't matter. Okay, if we were talking about who in what order they were going to present, it would matter. But the order doesn't. So there's 2 students, so it's a group. So it's a combination. I have a total of 7 students, and I am selecting 2 of them. So on your Inspire, it would be 7, 2. Plugging it into our equation here, 7 factorial over 7 minus 2 factorial over 2 factorial. So I have 7 factorial over 5 factorial 2 factorial, which gives me 7 times 6 times 5 factorial. So if you didn't have a calculator, this is the way you have to do it. Over 5 factorial 2 factorial. These cancel. 2 factorial is really 2. So 6 divided by 2 is 3. So I really have 7 times 3, which is 21. So there's 21 ways out of those to select 2 students. Otherwise, you can do the combination on your calculator. Okay? You would do 7, math. We're going to probability again. Notice number 3 is my combination. So it's 7C2. Hit enter. Maybe my 2 isn't working. There we go. And you get 21 ways. So either way you would like to do it, there it is. That is example 4. Okay. Moving on to example 5. 5 cousins at a family reunion decide that 3 of them will go to pick up pizza. Okay. How many ways can you choose the 3 people who will go? Well, this is going to be a combination because you're picking a group of 3 people. So I'm going to use combination. So it's really 5C, and I'm picking 3. So 5 factorial over 5 minus 3 factorial times 3 factorial equals 5 factorial over 2 factorial, 3 factorial. If I simplify, it's 5 times 4 times 3 factorial over 2 factorial, 3 factorial. Those cancel. 2 factorial is just 2 times 1, which is 2. So 4 divided by 2 is 2. So 5 times 2 is 10. So there's 10 ways. Once again, could I have used my calculator? Yes. I'm going to walk you through it one more time, and after that, I think we'll be okay. So I'm going to do 5, math, probability, combinations number 3, and we're picking 3 people to go, so 3. 10 ways. There it is. All right, example 6. We're going to be using the standard deck of cards. So here's our standard deck of cards. Notice that half of the cards are black, and then the other half are red. You guys have on your note sheet on the right-hand side a box at the bottom and said what makes up a standard deck of cards. So let's quickly talk about that. Standard deck has 4 suits. So there's 52 cards total. Sorry, 52 cards total. There are 4 suits. So 52 divided by 4 is 13. So there's 13 of each suit. And the suits are diamonds, so these are the diamonds, hearts, spades, and clubs. Okay, so those are what makes up our cards. So example 6 says 5 cards are chosen from a standard deck of cards. How many hands consist of 3 clubs and 2 diamonds? Okay, so here's where it gets a little bit trickier. Notice how it says and. Okay. And is a key word for multiply. Or is a key word to add. So we're going to multiply these 2 different groups. So I want 3 clubs. Well, I go back. How many clubs total are there? Clubs are a suit. So here's my suit. There's 13 of them. And I want to select how many clubs? I want to select 3. So this is a group. Okay, so I would have 13, and I'm selecting 3 clubs, times, I also want 2 diamonds. Well, how many total diamonds are there to choose from? Diamonds are a suit again, so there's 13. So it's 13C2. You could write all of this out on your, the equations out on your sheet, or you can just go to your calculator and type it in. So I would have 13C3, which gives me 286, and I would have 13C2, which gives me 78, so I have to take 286 times 78, times 78, and I get 22,308 possible ways to get a hand like that. So just kind of write out the steps. I figured out each one individually first, so it's 286 times 78, and that equals 22,308 ways. All right. Number 7 also refers to our cards. It says 6 cards are drawn from a standard deck of from a standard deck of cards. How many hands consist of 2 hearts and 4 spades? Okay, so whenever you see that and, we know multiply. So we got to figure out hearts. Hearts, once again, is a suit. There's 13 hearts total, so it's 13C2 times our 4 spades. Well, once again, there's 13 spades, so 13C4. We figured out 13C2 on the other page. It was 78 times. We need to figure out 13C4. So 13 math C4. That's 715. If I take 78 times 715, I get there's 55,770 ways. All right. We want to go ahead and try one last one. We have 6 cards again being drawn from a standard deck of cards. How many hands consist of 2 cards from one suit and 4 cards from a different suit? All right, this one is a little bit trickier. Notice they told us the suits before. Now they aren't telling us the suits, okay? So we want 2 cards from one suit and 4 cards from a different suit. So let's just think about it. If I pick any suit, how many cards are there to choose from? 13. So it's 13C2 times, now 4 cards from a different suit. Well, that other suit's going to have 13 cards, and I'm going to select 4 of them. Now, I think about it kind of like my counting principle. I'm picking 2 suits. For the first one, how many options do I have for a suit? I have clubs, hearts, spades, or diamonds. I have 4 options to pick the first type of suit. Then to pick my next suit, there's going to only be 3 options, because if I say this one's hearts, I only have clubs, spades, and diamonds to choose from. So it's the same as up here, except for now, since I don't know the suits, I need to figure out how many ways I could have picked those. So I do 4, because there's 4 suits to choose from for the first one, and 3 to choose from for my different suit. Okay, so my answer from above would be 55,770 ways times 4 times 3. And if I do that on my calculator, there's 669,240 ways to get a hand with 2 suits, or 2 cards of one suit and 4 cards of another suit. All right, that is the end of our Unit 5 Video 2. If you have any questions, please let me know. Otherwise, have a great day, and I will talk to you later.